Hello students, welcome back to my channel. I hope you all are fine. Okay, and now see now I'm going to give you most important, new chapter completely this one. So from this chapter you will get here 2 4 mark questions for final exam. Due to pandemic, situation means nothing but coronavirus. Okay, and now see a new chapter is gravitation. Okay, new chapter is gravitation. In that gravitation we are having sir 3 questions. First one is what is orbital velocity? Obtain and expression it. This is the first question. And second question is what is escape velocity? Here the same as it is. Obtain an expression for it. And third question is what is a geostationary satellite and what are the importance or what are the uses of it? These are the 3 questions. From these 3 questions, 100% you will get here 2 4 mark questions. Okay? And now see sir. Now come to the point. We are going to take here first question, that is what is orbital velocity? Obtain an expression for it. First of all, what is the orbital velocity? A minimum velocity is required for an object to revolve around a planet horizontally. Okay? I think you understood, sir. What is the orbital velocity? The horizontal velocity is required for an object. Okay? The horizontal velocity is required for an object to revolve around a planet in circular orbit. Around a planet in circular orbit. That is called here orbital velocity. Okay, that is the definition for orbital velocity, sir. Orbital velocity. Okay? What is orbital velocity? Let us consider we are taking here one object. Let us consider we are taking here one object. That object mass is small m, and let us consider we are taking here one planet. That planet of mass is capital M. Okay? So see here, sir. These objects, see, this is the radius, sir. This is the capital R, and the height of the height of the object it has from the surface of the planet is, that is h. That is h. So now this total height is, that is r plus h. I think everyone you understood. What is that? Let us consider we are taking here one planet. That mass of the planet is capital M and with radius capital R. And now we are taking here one small object, that mass is small m. That object can be revolving around a planet in horizontally. Okay? Around a planet in circular motion. Along a horizontally. Okay? That mass of the object on the surface of a planet height is, that is a h, and radius is capital R. Whenever you have to write from this object to center of the planet, the total height is here r plus h. Okay, sir? So now we have to take here let V naught be the, let V naught be the orbital velocity required for an object to revolve around a planet. When an object will be revolved around a planet, when an object it will be revolving around a planet, then the horizontally, then the centripetal force will be work. That centripetal force is equals to here gravitational force. So we can write here centripetal force is equals to gravitational force. Gravitational force. Okay, sir? So now see a centripetal force means we are having generally formula mv square by r is equals to, what is the gravitational force formula, sir? Means gmm by r square. G capital M small m by r square. Okay, sir? So here 1r cancel, we will get here. Then again mm also cancel. So we will get here v square is equals to gm by r. And remember, sir, the total height of this object is r plus h. So replace of small r we can take here r plus h, sir. Then v square is equals to gm by r plus h. Okay? Gm by r plus h. And we are having one condition. What is that condition, sir? Means here h value is less than r. So that's why we are going to neglect h value from the denominator. H value from the denominator. So then we can write here v square is equals to gm by r. Okay, but we are having one formula, the relation between small g and capital G. What is that one? Small g is equals to gm by r square. Gm by r square. Okay, now we can write here gr square is equals to gm. Okay, sir. Now replace of gm we have to write here gr square. So we can write here therefore v square is equals to gr square by r. 1r cancel. So we will get here v square is equals to gr. Then again v naught square. V naught means nothing but orbital velocity. Then v naught is equals to square if it goes to is equal that side, it will become here under root. That is under root of gr. So this is the our required formula. I think you understood, everyone. Okay, sir. What is the orbital velocity? Statement is very important here. Definition, and after the definition, explanation part. Okay, explanation part means nothing but we have to write how can we explain here same as it is. You have to write. Then 100% you will get here completely 4 marks. Okay, sir. And now, sir, next one. Next one, sir. Escape velocity. Okay. So replace of orbital. Now we are taking here escape velocity. Same question. So now here, sir, we have to take here. This is the escape velocity. So now we can write here first of all escape velocity. Sir, what is the escape velocity? Everyone, you know escape. Escape means nothing but dur chale aana. Okay? Sir, what is the escape velocity? Here, sir, escape means nothing but the minimum velocity is required for an object. The minimum velocity is required for an object to escape from the gravitational force. Okay? From escape from the surface of a planet opposite to the gravitational force. Okay? That is the here. That is called here escape velocity. Okay? That type of velocity is called here escape velocity. And now here, sir, we can write here explanation. What is this one? Explanation. What is that explanation, sir? See here, let us consider we are taking here one planet. That planet of mass is capital M. Okay, that planet of mass is capital M. And now we are going to take here, see, on the surface of a planet is mass, that is a small object we are taking. That object mass is small m. It has from the center of the planet. That radius is here capital R. Everyone, you know this one. Okay, now see here r is equal to h, means nothing but radius of the planet as well as height of the object. Both are equal. So now, so see here, at this position, see here, when the object has on the surface of a planet, some gravitational potential will be working on that object. So that gravitational potential is gravitational potential. Gravitational potential is equals to minus gm by r. Is equals to minus gm by r. So now again we have to take here another one again. So when the gravitational potential will be working on that object, so what is the gravitational potential energy, sir? Means then we will add here extra mass. That mass is the gravitational potential energy. Okay, there is a without energy, this is a with energy. Formula is same, minus gm by r into small m. We have to take it minus gm by r into small m. This is a okay, done. And now, sir, see here, let we are going to apply the here. some speed. Some speed means that was some velocity. What is that velocity? VE, escape velocity. When we are applying the velocity for this object to escape from the gravitational force, sorry, from the planet or from the surface of a planet opposite to the gravitational force, then we have to take here formula. What is that formula, sir? Means that is equals to kinetic energy. Okay, the kinetic energy is here, sir. That is equals to kinetic energy. The kinetic energy is how much energy it will be required, sir? Means that required here kinetic energy. Some energy will be applied, no? Okay, some energy is given to this object because of to escape from the surface of a planet. So that's why we are writing that kinetic energy is half mve square. Okay, and this kinetic energy is equivalent opposite to gravitational potential energy. This kinetic energy is equivalent opposite to gravitational potential energy. Gravitational potential energy. So we can write again half mve square is equals to minus of gravitational potential energy value is minus gmm by r, minus g capital M small m by r. Minus minus is cancel, small m also cancel. So now you will get here VE square. These two it will be divided. Whenever you have to take and go is equal that side, it will be multiplied. Okay. So 2 into gm, 2 gm by r. Here also we are having one condition. What is that condition? But we are having condition, sir. What is that condition, sir? Means the relation between the small g and capital G. Small g is equals to gm by r square. From this formula we can write here gr square is equals to capital Gm. So replace of Gm we can write here gr square in this equation. So therefore VE square is equals to 2 into Gm is nothing but gr square by r. So 1 r cancel. So you will get here VE square is equals to 2gr, then again VE is equals to under root of 2gr. This is the escape velocity formula. Okay, suppose if you want here, find the relation between escape velocity and orbital velocity. So now we have to take here relation between escape velocity and orbital velocity. What is that relation, sir? Means see, we are having escape velocity formula VE is equals to under root of 2gr. Okay, everyone you know. And now, sir, VE is equals to root 2 into root gr. Then again VE is equals to root 2 into root gr means nothing but there is a orbital velocity formula. So we can write here V naught. So this is the relation between orbital velocity and escape velocity. I hope you all understand this one. Once again you can check this equation part, and remember, sir, everyone, whatever you want, that one you have to message. Okay, you have to send the comments in comment box. I request you to all members. Okay. Once again, sir, what is escape velocity? Obtain an expression for it. Escape velocity definition. What is escape velocity? The minimum velocity is required for an object to escape from the surface of a planet opposite to the gravitational force. That is called here escape velocity. Remember. Okay? These are the explanation part. Okay? These are the explanation part. How can we write the explanation part? Let us consider we are taking here one planet. That mass of the planet is capital M. And let us consider we are taking one small object on the surface of a planet, which is at a distance r from the center of the planet. Okay. Remember, after that you have to copy this one, and then 100% you will get here 4 mark question. 4 marks. Okay. And after this we are having another one question, that is geostationary satellite. After this we are having here geostationary satellite, sir. I request you to all members, sir. 3 questions it can become in one video. Okay. Everyone, you have to see this video completely with concentrate, because of whenever you have to keep, concentrate, then 100% you will get complete video, sir. Okay. And now see here, sir. What is that one? Geostationary satellite. Question, sir. This one also 4-mark question. What is the question, sir? Means geostationary satellite. Geostationary satellite. Sir, what is the geostationary satellite? Okay, and write the uses of it. This is also 4-mark question. First of all, what is the geostationary satellite, sir? Means its period of revolution of an artificial satellite is equals to rotation of Earth. Its period of revolution of an artificial satellite is equals to its rotation of Earth. This is called here. Such type of satellites are called. Okay, such type of satellites are called here geostationary satellite. These geostationary satellite, it is required how much time, sir? Means it can be take here complete 24 hours. Okay, to complete one revolution. To complete one revolution, it can be take here 24 hours. So that's why we are telling here the time period of geostationary satellite is, the time period of geostationary satellite is 24 hours. That's why we are taking here. Okay, 24 hours, sir. Don't forget this one. And now see here the relative velocity with respect to the Earth is, okay. The relative velocity with respect to the Earth is 0. Don't forget this one also. Okay. This geostationary satellite is, suppose we can take it relative to the Earth is 0. Okay. And next one, sir, uses. What are the uses of this one, sir? What are the uses of this one, sir? Means to know the shape and size of the Earth. Okay. To know the shape and size of the Earth. This is the first one uses. And second one is to know the atmospheric pressure. Okay, and to know the space research in the space. Okay, and next one to know the forecasting weather. Okay, and also see here to know the properties of transmission radio waves. To know the properties of transmission radio waves. Okay, these are the main uses of this geostationary satellite. This one also 4-mark question maximum, sir. This question also came in the previous examination, and that previous examination also came. Okay, so I request you to all members, sir. I have given here in that chapter total 3 questions. In that 3 questions, 3 out of 3 was most important, sir. Out of 3 you will get here 2 questions in final exam. Okay, I request you to all members, please like and share and subscribe my channel. Okay, thank you, sir. Okay, bye.